Ok. Lo voy a hacer en inglés, por cierto, porque por algún lado que hay que hacer en inglés, pero so the influence of pitch feedback on learning of motor timing and sequencing of piano study analysis, that's the name of the paper. Okay. So before we get into the paper, I kind of want to talk a little bit about what sensory motor synchronization is. Each time you're playing like an instrument, each time you're doing something that has to do with music, you usually predict notes and you connect them with motor movements, right? If you're playing a piano, if it were completely silent, in theory, it would be kind of difficult to know what you're playing, because you kind of have that connection between your ears, which is the sensor, and the movement, which is your fingers. So before I get into the paper, I want to basically talk about the table of contents of this talk. We're first going to talk a little bit about the authors, the introduction. We're going to discuss the experiment and the result analysis. Finally, conclusions. So there were three authors. First one was Claudia Lapp. She's from the Institute of Biomagnetism and Biosignal Analysis from the University of Münster. This is in Germany. We have Markus Lapp. He's from the Institute for Psychology and Otto Creutzfeldt Center for Cognitive and Behavioral Neuroscience. This is also in the same University of Münster in Germany. And finally, we have Peter E. Keller. He is from the Marx Institute for Brain, Behavior and Development, and he's from Australian university called Western Sydney University. So going to the introduction, a little bit about what I said before. The sensory motor synchronization is important in our day-to-day life because we tend to connect our sensors with our movements. And a great example of this is in music. It's a more visible example for people to kind of study. And so in this, we have two types, right? We have motor predictions and melodic predictions. With motor predictions, we are talking about movements, right? Imagine you have a piano in front of you, and for people who are pretty have studied piano, sometimes they know that without even hearing the song, they can already play it because they have kind of like a motor, what we call like a memory, right? And then we have melodic predictions, which is more auditory. And so imagine you're hearing a song, you've already heard that song, you expect something after each tone because each pitch, because you've already heard that song, so you expect something from that. And that also helps us with anticipating the auditory consequences, which is basically if you're playing an instrument and you make a mistake, you learn from that and you adapt and you correct your movement next time. Or sometimes before you're even going to make the movement, you already know that it's not going to sound that way based on your position, and you're going to correct your movement. This is kind of one of the theories that they're using in machine learning, in fact, currently, where they're trying to adapt in the same way humans do by learning with their movements. So we want to discuss the purpose, right? The purpose is basically we want to investigate, or they wanted to investigate, the role of prediction in newly acquired musical skills. So a person that's never really used an instrument, and they use a metronome as part of the synchronous part of the test. And the hypothesis for this paper was that a match in pitch between a planned finger movement with the auditory outcome assists in sequencing and sequence learning and timing performance. So that basically means that the planned movements that you're going to do with the audio of the pitch and everything helps you learn and helps your performance in terms of learning a musical instrument. So first, a little bit about the methods. for this paper. So in terms of participants, we had 29 musician students. They were aged between 17 and 38 years old. None of them had neurological issues. Only one of them was left-handed and the rest were right-handed. And none of them had issues performing the tasks in terms of like motor, right? The materials were, we had a melody comprising of 15 notes, and this was used as a stimulus material, basically what they were going to play. The melodic sequence was noted in a binary meter and in the key of C major. They had a piano, and that piano was connected to a laptop. And they had the auditory feedback was manipulated by that computer. This was part of the experiment that they had to do. And finally, metronome was had a rate of 2 hertz. So a little bit about the procedure. First, there was an experimenter, and they instructed all the participants on how to play a sequence. So basically, there was somebody there explaining them what to do. The participants then practiced the melodic sequence for about 10 minutes with normal auditory feedback. Then the participants practiced another 5 minutes, but now with the metronome on. So they basically had little ticks going on, and then they had to practice. This is for the timing part of the experiment. And then we had the auditory feedback. And then they were divided in groups, right? Basically blocks. And each block they played 20 sequences. And the blocks were repeated 4 times, resulting in 80 sequences for each feedback, which there were 3 tests that I'm going to explain in a bit, which meant that there were 240 sequences altogether. So the test had 3 parts, 3 main steps. In the first test, what they did was basically, it was a normal piano with a normal sound. So each key you press had a specific tone. And so if you press A, it would sound like an A, and like just like that. And then the second, it employed a fixed pitch auditory feedback, and that would consisted of a single tone with each keystroke. So this meant that each time you pressed a key, it had one sound. It didn't matter if you pressed third key or the first key or the fourth key, it doesn't matter. They all sounded the same. And then the third condition was where each time you press the keystroke, there was a randomly generated sound. So that meant even if you press the same key twice, it would have different sounds each time. So it's kind of like, as you can assume, it's a little bit confusing for people. So based on this, going to the data analysis part, some notes for the data analysis was we wanted to get the percentage of correctly played sequences. We wanted to get the mean and standard deviation of the onset intervals between 2 successful keystrokes. They obtained the mean and standard deviation of the temporal offset of the metronome. And an important thing was they used a detail of the experiment, basically, was that they performed using software package Mathematica 9. And the statistical analysis was done in the programming language R. So a little bit about the results. In this image that you guys can see here, that was basically the percentage of correctly played sequences. So that means that correctly played keys, right? They had to basically do it again. And it gives us some detail already, right? It shows us that in the random one, it did affect significantly. The fact that you had random sounds kind of made people get confused on which was the next key. And so that showed us a little bit more interesting information. But it did show us that also there was no difference in the accuracy of the normal sounding keys and the single sounding keys. So even if you played like the same sound always in each key compared to like normal sounding piano, it from their perspective, it seemed that the results were the same, basically, almost the same, statistically the same. So here's other results that the paper provided us. So in A and B, you can see the inter onset interval and the standard deviation of the inter onset interval. And we didn't really they didn't really find any difference between the conditions. In C, you can see the signed asynchrony to the nearest metronome beat, and they didn't see that much difference between each one. Statistically speaking, again. But in the D, they did find something interesting. So in D, what they found was that the variability between the single tone condition was lower than the random and the normal. So what does that mean? That basically means that the speed and the exact moment the tick sounded and the moment they pressed the key was a lot sharper when there was a single tone compared to when there was normal tones and random tones, which basically kind of told them that in a way the brain kind of got had to go through more, because when there was just one sound, they could focus more on the speed and less on the auditory part. Whereas when they were in a normal, where you were hearing the auditory part, in a way the brain kind of got confused. Not confused, but it was working on something else. In the random case, you could see that they did get confused, right? And so going to the conclusion of this, they found that non-musicians produced more sequencing errors on newly learned piano playing tests when the auditory feedback was random and unpredictable. So a person that never played piano, a person that wasn't really a musician, had more errors, which, as I said before, when the auditory feedback was random, like every time you press the key, it was a different sound, and that kind of confused people and their brains. And the performance timing was most accurate when one tone was given as an auditory feedback. That they also found that for musical novices, there wasn't really a difference between the single tone and the multiple and the normal tone, which meant that basically as a non-musician, you didn't really need to hear the auditory part in order to play your notes correctly, which is an interesting outcome. But that when they are random, it does affect. So it's kind of like counterintuitive in a way, because it's not affecting you if it's not there, but if it's random, it is affecting you. That's something to take into consideration. And this also gave us some things from the paper, because based on the tests they did and everything, as we were seeing in the class before, we did encounter that this test was only done once, and the people inside the test already knew or expected what the test was going to be about. So it kind of didn't follow some basics of research, in my perspective. That was one of the big problems that I would say that had this paper. They only tested it once with these amount of people, and it was only done one test one afternoon with a specific group of people from one specific university in one specific place, when one specific set of tools and data. And so what I would do to improve this paper specifically, I would test it with more groups, and I would try to bring more data into it to understand if it's if the statistics would change with more people. But other than that, I didn't see that many problems with the paper. Let's see. And yes, I think that's the last of my presentation. Any questions?
Muchas gracias, Christopher. Más adelante vamos a, ya la semana que viene podemos empezar a ver un poquillo de estadística para ver con el valor, el p-value que vimos ahora más temprano, si nos presentan números, sí, pues qué validez tiene la probabilidad de que efectivamente los resultados que reportan sean correctos, pero eso es parte de lo que desarrollaremos en el curso. Este paper a mí me llama la atención porque presenta a lo que a mi parecer un resultado anti-intuitivo. Y bueno, está anti-intuitivo. Yo toco un poquitillo de piano y yo tengo una sospecha que si se hiciera una investigación de recabar información por algo que se conoce como criterio de experto, a mi parecer, muy probablemente el criterio de experto hubiera estado equivocado con lo que la evidencia de este paper muestra. De que no, claro, el estudiante tiene que oír la nota correcta para aprender y no, parece que es más importante la memoria del movimiento de los dedos, entonces hace el resultado ahí pues interesante. Y el agregar aleatoriedad a la nota más bien enreda. Entonces, en ese caso, lo que dice es que la realimentación auditiva que usted tenga no es de que no es valiosa del todo, sí sirve para empeorar.
Sí, eso me parece gracioso.
Sí, entonces no es de que es inválida del todo, sino que sí sirve para empeorar. Este paper hay que rescatarle hicieron muchas cosas bien. Por ejemplo, vete al slide donde está la documentación de los sujetos, de la manera en que se seleccionó. Bien, esa. Sí, eso está bien hecho, están documentando. Hubo también una parte donde mencionaron las herramientas.
Sí, aquí.
Muy bien. Entonces, dan materiales y metodología y el procedimiento que se ejecutó. Esto es una excelente práctica. De hecho, ustedes, para su tesis, les digo que va a ser bastante elegante. Si ustedes llegan y ponen un link de GitHub que dicen, vean, ahí están mis datos y ahí está el script con el que analicé. Ahí lo tienen por si gustan revisarlo. Incluso, por ejemplo, en una tesis que yo estoy dirigiendo, queremos comparar si lo que está proponiendo mi estudiante es mejor a soluciones de otros. Y resulta que no se tiene acceso a lo que hicieron más que el resultado del paper, pero no se tiene ni acceso al algoritmo de ellos, no se tiene acceso al conjunto de datos, que es lo que haría que la comparación sea válida. Entonces, es chido que incluso sin un paper llegan ustedes a publicar, que pongan eso disponible. Estas son partes que considero que están bien hechas. Tal como mencionabas, idealmente más participantes, más repeticiones, pero tenemos limitaciones prácticas, que es una consideración que hay que tener. Entonces, con lo que tenemos, sacar la mayor cantidad de información. Ahí,
Sí, a mí,
ajá.
¿no? Yo, a mí me parece interesante porque es una prueba que no se ocupa mucho, o sea, dinero, pero solo lo hicieron una vez. No es como el caso de los ratones, que se van a matar ratones, entonces ahí sí solo tengo plata para 100 ratones, pero en este caso me pareció que hubieran podido hacer un poco más, siendo una prueba relativamente barata.
Correcto. Ahí, Christopher, bueno, por ser la primera semana, la realimentación para los primeros no pesa tanto. recordar y un par de cosillas, pero esto es para los demás. Esto tal vez vos no lo tenías claro, no está en los documentos. Para los que presenten adelante el análisis del experimento, póngalo en un slide, en una filmina aparte para que esté disponible. Y agreguen el slide final de gracias. Entonces, ese
Ok.
par de cosillas menores. Te agradezco un montón, Christopher.
Ok, estoy intentando buscar el botón para dejar de compartir.
Profe, una pregunta.